Hello, I'm part of GE Inspection Technologies, and today we're going to go over a little bit about applying phased array to the AWS code. We've had several customers ask us how to go about this, how to do it, and so what we've done is a couple of things. First, we created an array, and we've actually had it for quite a while now, an array that mimics the parameters of the standard conventional probe. And we've also come out with a guideline on how to use it. Now the guideline is written in procedure format, and I guess one of the things that we wanted to do was, or one of the things we didn't want to do, was to overcomplicate this and change everything around and reinvent the wheel. The AWS processes have been in place for years, and they're good, solid processes, and so there was really no need to go through and reinvent everything. What we did is we took the most popular selling conventional probe that we make, and then we built an array to mimic it. Now, one of the things that people have a hard time understanding is an array of a given size will have the exact same acoustical properties as a conventional probe of the same size. So what you end up with is pretty much apples to apples. And as you can see, we even use the standard conventional wedge for it. I've always said that phased array can be as easy as you want to make it or as complex as you want to make it. My own self, I prefer easy. So when we went through and we wrote the guideline for this, we kept all of the same standard processes in the AWS. And to anybody looking at this, it will be familiar and probably looks much the same as the procedure that they're using today. We changed nothing in it. So this is our Phaser XS. It's our handheld portable manual phased array unit. And what we've got is it's hooked up to the 16 element AWS array that we built, and we're going to run through a few points here and a couple differences between phased array and conventional. First thing we're going to do is set up a linear screen range on this. And as you can see, if I push the home button and toggle the right knob, I basically scroll through all my angles. I don't know if you can see that little beam angle there, but that's telling me which angle this red cursor's on. Okay, so we're gonna mimic a quick inspection here and say the code tells me I need to use a 70 degree. So I am going to set that beam cursor to the 70 degree angle, and that is going to bring up my 70 degree A-scan. Now, I'm on the IIW block looking at the 2 and 4 inch reflector. As you can see here, there's a 2 inch and there's the 4 inch. So what I'm going to do to get this linear is I'm going to go in this little Cal sub menu, and this has everything in it that I need to to produce a linear screen range. So first thing I'm going to look at here is this 4 inch reflector. I'm going to max it out in the A-scan and run my gate across it, so I'm measuring that signal. And you can see I have a sound path of 3.918. So I'm going to adjust that with my velocity. I'm going to change my velocity until that reads 4 inches, as it should, or as close to it as I can get. The next one I'm going to look at is the 2 inch reflector. And so I'm going to run my gate across the 2 inch reflector. Give it just a little bit more gain. And so now I'm reading 70 degrees on the 2 inch reflector. Let's go back and forth a little bit on that. Make sure I have that signal peaked out. And for this one, I'm going to adjust my probe delay until it reads 2 inches. Or as close to it as I can get. There, exactly 2 inches. So now my screen range is linear. The next thing that I'm going to go over is describing the exit point. Now the wedge that I'm running on is the 60-degree wedge, even though I'm looking at the 70-degree angle. And with phased array, I'm currently running 35 angles. I'm sweeping 35 to 70 degrees. So literally I'll have 35 separate exit points. The machine knows this. And so what it does is it gives you a default 0. And that's going to be in my wedge definition here. When I go through and I describe the dimensions of the wedge for it, it's going to ask me what the wedge front is, because it's going to set that as a 0 datum for measurement points. So anything on the surface distance I have, it's going to measure out from the front of that wedge out across the surface to it, and so on and so forth. Now, the code tells me that I need to locate my exit point. So if I go along here, I can see that my 70-degree exit point is going to be right out in front of where my 60 would be. So I'll make a simple mark on the side of the wedge for that, like that. And there's my 70-degree exit point. Now, the next thing that I need to do is to get a reference gain. So let's flip the block over. We're going to look at the 60 thousandths hole with the 70-degree angle. So, get that in here, and I can see that this is my hole floating across here. Now I see that with all angles, but I'm only going to record it with the 70-degree angle. So I'm going to bring that into the A-scan. Come in and adjust my gates a little bit. Give it a little more amplitude. And the code will also tell you to set it between 40 and 60%. Okay. A little bit more, not today. So let's see if we can go for an even 50%. Okay, there's 50% right there. And this is what I'm going to record as my reference level. Now, okay. So that being done, there's two ways I can do this. There's two sides of gain in here, and I'm not going to, for the interest of time, I'm not going to go through and describe them in great detail, but there's a digital gain and there's an analog gain. Okay, there's a couple of ways to set your reference. You can use, say, your digital gain to run the 60 thousandths hole or your reference reflector to a reference level, or you can use analog gain to do it. And then on top of that, compensate with your scanning gain. So what I've done here is I've just used the analog gain. But it can be done either way. Another thing you can do is if you're only using one side of the gain, you can activate your the gain on your home screen, whether it's digital or analog, and it'll give you a plus dB value for your scan gain. So your reference is at 18.4, and you go above that, it's telling me up here how much above that reference level I am. Okay, and you can toggle the two gains back and forth in this by simply pressing and holding the step button there. Anything in this menu runs off the right knob. Your gain in this window runs off your left knob. Okay. So we have a reference level at 18.4. The next thing we're going to do is take a look at this plate, which has an artificial or a man-made flaw in it. So now we're just going to run a quick simulation and show you how to adjust your screen range for the part that you're doing. Right now we're going to take a quick look at this 1/2-inch thick plate. So I'm going to come over here in my material thickness, and I'm going to dial that down to a 1/2 inch. And I want to make sure that I have enough screen range that I fully encompass my second leg. And so the way I'm going to do that is, after I get my part thickness set correctly, come back out on my home screen, I'm going to go into this leg function. And if I set that exactly at 2, what that's going to give me is 2 legs with the 70 degree in that part thickness. So I'm going to go a little more than that. We're going to give ourselves a little bit of room. It's always a good idea to give yourself a little bit more, and say at 2.4. Now, I'm not really concerned with how that's going to measure out or using nice round numbers, because the machine tells me pretty much everything I need to know for measurements to flaws, surface distance, sound path, and so forth. So I can recalculate that, press and hold the home key. Basically what it's doing is redrawing the pixel mapping. It's not going through any UT functions. It's just redrawing the pixel mapping in that case. I'm going to kick in some gain here. We'll say just running about, I don't know, 14. Just picking a number. So in looking at this plate, we're just going to do some quick raster scans here. You can see all of a sudden my screen's getting really noisy. I've got a lot of garbage coming up in this general area here. Being carbon steel, this should be a clean weld. You should see nothing in there, and there's probably something else right there as well. But I'm not interested in those low angles. I'm not going to take this and run an angle down and start measuring with an angle that the code doesn't prescribe. I'm going to stick with my 70 degree. And what I'm going to do is I'm going to get everything really hot there, and I'm going to run this out to my 70 degree. And you can see it over here in my A scan. This is that signal that we're looking at. And actually it is a crack in the mid wall of this weld. So let me pull a little bit of gain out of this. And actually I'll take this and run it down to what our reference level was, which was, I believe we set at 50 dB. So we're going to peek this puppy out. Keep dropping a little bit more gain. That down there. Make sure I got a good, nice hot spot on it. Here. Okay. We'll say that's it. So I'm going to run that down to 50%. And this is going to be your indication level that goes on your report form, the old formula A minus B minus C equals D. Now for the attenuation factor, I'm going to use SA. That's my sound path. I have it up here in this results window and also displayed in my larger window. That's my sound path that I'm going to use for C. And so given that information, you run it through the same form that you always have, and you come out with your indication rating and accept or reject by the code. And everything is the same as conventional. The only difference being is you have the advantage of looking at this sector image and seeing what's happening at different angles. And it gives you a lot more information than you ever had. By contrast, if I leave that on 70 degrees and I come over here and look at just the A scan, okay, there's my crack there, I think. I see nothing else. I'm not seeing anything else when I'm up here looking at these low angles, a couple little pips coming by the screen. But I'm not really catching that full picture that I had when I was running just the sector image. There's a lot of advantages and a lot of built-in flexibility with phased array. The biggest advantage to me has always been this image. This image is priceless. It tells you a lot more information than what you need. I can easily see that there's a difference between this clean part right here and this part right here. And remember, we've turned all of our gain out of this. And that's pretty much the gist of it, pretty short and quick.